Okay, so for this question, NaOH is a base and is a strong base actually, and strong bases can conduct electricity because they dissociate into ions. So it would be number 3. For the next one, 0.02 molarity, 2 significant figures because 2 and 0, the leading zeros don't count. And ratio of oxygen to carbon dioxide is, right, 3:2. Occurs in the beaker. So here we have electrolytic cell. So the reaction that's happening in the beaker is definitely not spontaneous because this is electroplating, and electroplating is a non-spontaneous reaction, so we can cross out 1 and 2. And there's a power source, so it's using electrical energy to make chemical change. So it'll be number 3. And then this one, representing H+ acceptors, would be the bases. So the 2 species that are the bases are water and SO4. Draw a Lewis dot diagram. Ammonia is NH3, and the nitrogen has 5 valence electrons, while hydrogen has 1, so total of 8 electrons and 4 pairs. So you would draw it like this, with H's on the side. Compare the energy of electron first shell to the second shell. So the energy in the second shell of the copper atom would have more energy because the electrons in the second shell are farther away. So the electrons in the second shell feel less attraction to the protons in the nucleus than the first shell do. The numerical setup. So you would do the atomic mass multiplied by the abundance as a decimal. So it would be 62.93 times 0.6915 plus 64.93 times 0.3085. 08. Yep. And just a numerical setup, you don't have to solve. Identify element in period 2. Okay, so this one is the one that is located along the staircase, and that would be boron, or you can write B, I think, but I'll write boron. And least amount of energy. So this one would be lithium because in terms of electron configuration, it has 1 unpaired electron. So that is really just up for grabs, if you will. And then trend in atomic radius, it's decreasing as you're increasing an atomic number because the size of the nucleus is increasing. So there is a more strong attraction. So the bigger nucleus is pulling in the shells, the electron shells inwards. So it's a lower atomic radius. And then balance in your answer booklet. I'll just balance on here, I guess. So, and yeah, I think everything adds up. 2 nitrates, potassium, and iodine. Yep. It's usually the ones that have lower oxidation numbers that need to have a higher stoichiometric ratio. And then the product is potassium nitrate because the NO3 is nitrate and it's in the polyatomic ions table. And then the gram formula mass of the yellow solid compound produced by the reaction would be lead iodide. I need to get my reference table because I don't have it here. Oh my gosh, it's falling apart. Okay, so the I is 126.904. Oh. And then the lead is 207.2, I think. So yeah, you would do, to find the gram formula mass, you would do the lead plus 2 times the iodine, because it's PbI2 and not PbI. So you have to remember that, take that into consideration when you're finding the gram formula mass. So 207.2 plus 2 times 126.904, that gives 461.008, which is basically 461 grams per mole. And then substance on table H, because so that would be propanone, because it goes up the fastest, faster than everything else. And then yeah, that shows you, because high vapor pressure is weak IFAs, so that one has the weakest IFAs. And then the vapor pressure of ethanoic acid, this is just, look at the table at 50 degrees Celsius, and it's about it's less than 10. I would say it's between like 7 and 9, so I'm gonna say 8 kilopascals. And then charge distribution while water is polar. So oxygen has electronegativity of 3.4, and then hydrogen is 2.2. So the hydrogen will be partial positive, and the oxygen will be partial negative, because it's more an electronegative. And then if you draw the structure, you can see that the hydrogens are both partially positive and the oxygen is partially negative. So if you draw lines of symmetry, you would see that the charge distribution is asymmetrical. So you can just say asymmetrical distribution of charge as your justification as to why water is a polar molecule. Like, yeah. And then this one is a reference table question. This is an alcohol functional group. So molecule A is an alcohol. And then dimethyl ether. So you also would look at the functional groups part of the reference table, table R, I think. And the di in dimethyl means 2. Methyl is 2, like 1 carbon branch off of the main structure. And this is the ether functional group. It has an oxygen and then two different carbon chains off either side. So for dimethyl ether, we would have 2 1-carbon chains with an oxygen in the middle. Chemical name for the compound. So it has an organic acid functional group, like I circled, and this one would be ethanoic acid, because the eth is for the 2 carbons in this compound, and then you know, it has the organic acid functional group. So yep, ethanoic acid or acetic acid, depends on how you were taught. Most active, least active. This is a table J problem. So the least active metal here would be silver. And then you can also look just by the reactions it has. Like silver is only one with 4 no reactions, so it's pretty not reactive. And then as for the most active metal, that would be magnesium. It's the highest on table J out of all these, and it also reacted 3 times. So that shows that it is higher on the activity series, because reactions only occur when the metals being replaced is higher on the activity series than the metal that's already there. So the most is Mg, and the least active is silver. Oxidation state for nitrogen in AgNO3. So NO3 has a -1 charge. You can determine that by looking at the polyatomic ions table, or just by knowing that silver nitrate has to be balanced out and silver's +1. So the oxygen has -2, and there's 3 of them, so that's -6. -6 plus X, which is nitrogen, is -1, so X is 5. The balanced half reaction for oxidation. So the most important word here would be oxidation, because that tells you that the zinc is losing electrons. So that the zinc metal has to be on the left, and then the electrons along with the zinc ions have to be on the right side of the reaction, the arrow. Metal can be cathode. Other students to excel. So I would just go with silver, because that's usually the safest cathode choice, because metals that are very not active are typically what's used as cathodes. So yeah. Okay. Dissolving. Okay. Endothermic process. For this one, you should read this little excerpt they give you. It's very helpful. It gives you actually information you need to answer the question. So endothermic processes, the temperature of the solution decreased, according to the excerpt. So as the dissolution of ammonium chloride happened, the temperature of the solution decreased, which indicates that while the dissolving happened, the system was absorbing energy from its surroundings, and that is exactly what an endothermic process is. Endothermic processes take away energy from their environment in order for the reaction to happen. So the dissolving of ammonium chloride absorbed energy, thus decreasing the temperature of the solution. This one's a table G problem, like saturation, dissolution, stuff like that. Okay, so 46 in 200 grams of water, and then table G, just finding the curve, it's kind of hard to read. 37 grams of ammonium chloride per 100 grams of water at 20 degrees Celsius. So this will mean that this solution is unsaturated, because typically you'd be able to dissolve more than 46 grams in that 200 grams of water. Determine number of moles dissolved in 200 grams of water in the investigation. Okay, so this one you would just get the molar mass. The gram formula mass. So I'm just gonna estimate here. I know nitrogen's about 14, hydrogen's about 1 times 4, and then chlorine's about 35.45. So then I add them together in the calculator, and I get, let's see. Sorry, I'm a slow typer. Oh, wait. Did I miss a problem? Oh, I missed 71. Oops. Okay. Wait, no. I missed 72. Oh, let's swap that. Okay, so the closest solute is NaCl, because looking at the table G, the curves of NaCl and ammonium chloride are almost intersecting. So yeah. Okay, back to 73. So this is about 53.45. Okay, so they gave 46 grams to start with, and this is a gram formula mass. So you would get 0.8606 moles of ammonium chloride that's dissolved in the solution.